Assalamualaikum and good day everyone. My name is Nurul Wahida binti Azizi. My student ID is 2025860938. So, today I would like to explain what I understand about differentiation and the technique of differentiation. So, differentiation is a branch of calculus used to determine the rate of change of one variable with respect to another. It is the process of finding the derivative of a function. Differentiation is important because it helps us analyze change in quantities and solve problems in mathematics, science, engineering, and economics. There are several techniques of differentiation. The first one is the constant rules, state that the derivative of a constant is always zero. The second one is power rules is used for function in the form of x power of n, where the derivative is nx power of n minus 1. The product rules is applied when two functions are multiplied together. The quotient rules is used when one function is divided by another function. The chain rules is used for composite function, where one function is inside another function. We also have the exponential function, where the derivative of e to the power of x is e to the power of x. And the natural logarithm function, where the derivative of log x is 1 over x. In addition, differentiation can be applied to trigonometric function. For example, the derivative of sine x is cos x. Derivative of cos x is minus sine x, and the derivative of tangent x is secant square x. Other important trigonometric derivatives include cotangent x, secant x, and cosecant x. In calculation, differentiation is an essential topic in calculus because it helps us understand and measure rate of change. By learning this differentiation technique, we can solve a wide variety of mathematical and real-life problems.
Hi, my name is Siti Asyaismi binti Muhammad Zaidi, and I would like to discuss question 2. Find dy over dx for the following functions. So how to find dy over dx? There is 5 basic derivatives to find dy over dx. The first one is variable, bracket or chain rule, product rule, quotient rule, and constant. So we look to question A, 6x cubed cosecant x minus 2. So as we can see, the relationship between 6x cubed and cosecant x minus 2 is multiplication. So we need to use product rule. The formula for product rule is dy over dx uv prime plus vu prime. So to find dy dx, first we need to find u prime, v and v prime. So we took 6x cubed as a u and cosecant x minus 2 as a v. So to find u prime and v prime, you need to differentiate. So we get the value v prime and u prime. So after we got a value, we need to insert into formula. So we insert into formula and we need to simplify and we got the answer. Question B shows that the relationship between 2 minus 2x and secant x is divide. So we need to use quotient rule. The formula for quotient rule is dy over dx equals to vu prime plus uv prime over v square. So first we need to find u prime, v and v prime. So we take c minus 2x as a u and secant x as a v. So we need to find u prime and v prime. So we need to differentiate u and v. So we got the value. After that, we need to insert value into formula. Insert the value into the formula and simplify, and we got the answer. That's all from me.
Hi, Assalamualaikum. My name is Nur Nadira binti Muhammad Sazali. Now we are going to answer question 3. Given 10 cubed xy squared plus y equals to x, find dy dx using implicit differentiation. So first, we will differentiate both sides. 10 cubed xy squared plus y is a composite function. We must apply the chain rule in order to differentiate it. The derivative of 10 cube u is 310 square u secant square u. Then I multiply the derivative inside the function, which is u equals to xy square plus y. To differentiate u for the term xy square, I use the product rule because it consists of two functions multiplied together, which is x and y square. After we have done that, the value that we get for du dx is 2xy dy over dx plus y square plus dy dx. Then we substitute back the u value and the du dx value back into the term. I then expand the brackets and collect all the terms that contain dy dx on the left side, and the remaining term that doesn't have dy dx will be moved to the right hand side. After I factorize dy dx, I then simplify the equation inside the bracket, which give me 310 square xy square plus y secant square xy square plus y, 2y plus 1 equals to 1 minus 3y square 10 square xy square plus y secant square xy square plus y. And finally, I will divide both sides by the bracket expression to isolate the dy dx by themselves. So therefore, this is the final answer. And that is how implicit differentiation is used to find dy dx for this equation. Thank you.
Assalamualaikum, my name is Noor Arfa Alia. Today I want to share how to solve question using the linear approximation. Okay, first we have to know the formula. The formula for differential approximation is fx naught plus delta x. It is approximately with fx naught plus f prime x naught delta x. Okay, so first we know x is 81.02. So the nearest number of 81.02 is 81. So the x naught is 81. So we know delta x equal x minus x naught, and we will get delta x 0.02. Okay, next step is we have to define the function based on the question. We can define the function as fx equal 4 root of x plus 1 over square root of x. Or we can write it like this: fx equal x to the power of 1 over 4 plus x to the power negative 1 over 2. Okay, so next step, we have to differentiate of f prime x. Okay, so we will get f prime x equal 1 over 4 x to the power of negative 3 over 4 minus 1 over 2 x to the power of negative 3 over 2. Okay, we can simplify it to 1 over 4 root of x to the power of 3 minus 1 over 2 square root of x to the power of 3. Okay, so next we have to find the value of x naught and f prime x naught. Okay, we have substitute x naught, which is 81, to the these two formula. Using the calculator, we will get f x naught, we will get 3.11, and for the f prime x naught, we will get 0.00857. Okay, using this formula, f x naught is 3.111 plus f prime x naught 0.00857, and multiply it with delta h, which is 0.02. And then we calculate, and we will get 3.1111714. And read the question. We have to give 3 decimal place, so we have to write 3.111. Okay, so that's the final answer.